Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 9, Lesson 7 on the quadratic formula. Our friend, the quadratic formula, right? Now you use this quite a bit in Algebra 1 and I think that what we're going to do today is probably not going to be very new to you. So let's jump right into it and play around a little bit with the quadratic formula. So first, let's talk about solving a quadratic with irrational solutions. Back in Unit 7, we reviewed how to solve a quadratic equation using completing the square. But back there in Unit 7, our solutions were all rational numbers. We didn't have any irrational numbers. We can use this method even when the solutions involve irrational numbers. And the main irrational numbers aren't going to be things like pi, but they're going to be like square roots of non-perfect squares. So the square root of any non-perfect square is an irrational number. So let's take a look at that process in exercise number 1. Solve the following quadratic equation for all values of x by using the method of completing the square. Express your answers in simplest radical form. All right, well, let's review how to solve a quadratic by completing the square. Let me just go back to blue here. All right, so the first thing I always like to do is to remind students that completing the square only works when the leading coefficient is equal to 1. Fortunately for us in this problem, it is equal to 1. So we can use completing the square. Now, if there's a constant term, like this plus 1, what I always start with is moving that positive 1, or whatever the constant is, to the other side of the equation. So I'm going to have x squared minus 6x is equal to negative 1. Awesome. Now, at this point, what I do, keep in mind we did this back in Unit 7, is I'm going to take the linear term, or the coefficient of the linear term, in which case that's negative 6, and I'm going to find half of that, which is negative 3, and I'm going to take my negative 3 and square it, and I'm going to get 9. And I'm going to add a 9 to both sides of this equation. Now, when I do that, what I will always end up having on this side of an equation is a trinomial that when I factor it, the two factors are identical. And in fact, if we think about this for a moment and we think about our factoring work, right, when I'm looking for two numbers that have a sum equal to negative 6 and a product equal to positive 9, those two numbers are negative 3 and negative 3, right? Negative 3 plus negative 3 is equal to negative 6, and negative 3 times negative 3 is equal to positive 9. So the left-hand side of that equation factors into x minus 3 times x minus 3. Of course, the right-hand side of the equation is just 8. And now, because we have identical binomials there, we can rewrite this as x minus 3 quantity squared equals 8. So all completing the square does is allow us to put this quadratic into this form. All right. Now, by the way, notice that the number that's actually in here, x minus 3, happens to be this number. And that's not a coincidence. It always will be that number. So whatever the half the b is, it's going to be x plus that number. In this case, x plus negative 3 is x minus 3. Now, the beautiful thing is, the reason we want it in this form is we can now solve this using inverses. In other words, I've subtracted 3 from x, and then I've squared it, and I've gotten 8. All right, to undo that, I'm going to take the square root of both sides and then add 3. Keep in mind, and we talked about this just a few lessons ago, because I'm taking an even-powered root, I'm going to get positive or negative square root of 8. All right. Now I can add 3 to both sides, and that's going to give me 3 plus or minus the square root of 8. And the only reason I'm not done is because the problem tells me to put my answer in simplest radical form. So I can now write this as 3 plus or minus the square root of 4 times the square root of 2. And that's 3 plus or minus 2 times the square root of 2. There we go. Now, it's kind of interesting because people always think about completing the square as an algebraic technique that allows you to solve a quadratic. It really doesn't, right? What completing the square does is it puts it into a form that we can then use inverses on in order to solve the quadratic. We can't use inverses on this thing or this thing to solve a quadratic, right? But as soon as we have it into x plus or minus some number squared equals a number, then we can take the square root of both sides to get rid of that. Then we can add or subtract as we need to get rid of the number that's being added or subtracted to x, and then we get our final solution. Now notice how algorithmic that is, right? Step 1, get the leading coefficient equal to 1. Step 2, take the b and divide it by 2 and square it and add it on. Step 3, write this thing as a binomial squared. Step 4, take the square root, etc. Because of all of that, it leads to the quadratic formula. Since any quadratic can be solved using completing the square, a formula can be developed that will solve for the roots of any quadratic equation. This famous formula, known as the quadratic formula, is shown below. You worked with this as well in Algebra 1, so let's review the quadratic formula. The solutions to the quadratic equation ax squared plus bx plus c equals 0, assuming that a doesn't equal 0, are given by x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. This is quite possibly one of the most famous formulas in all of math, and again, you can actually derive this formula. You can come up with it by completing the square on this general quadratic equation. That's beyond the scope of this course, so we're not going to do it here, but it is kind of an interesting and fun challenge. Interesting and fun, I'm sure. So let's take a look at exercise number 2. Using the quadratic formula shown above, solve the equation from exercise number 1, letter A. First, state your answers in simplest radical form. Okay, now we already know what the answers to this equation are, or what the solutions to this equation are, okay? But what we want to do is show that by using the quadratic formula, which is what I would call a plug and chug formula, you plug numbers in, you kind of chug through the math, and you get answers, we're going to get exactly what we got before. Now, the first thing we have to do is identify the values of a, b, and c. A is the coefficient multiplying x squared, b is the coefficient multiplying x, and c is the constant added on. So, first thing I always do in any quadratic formula problem is identify a, b, and c. A is equal to 1, b is equal to negative 6, and c is equal to positive 1 as well. So now let's just substitute these in. X is equal to negative 6 plus or minus the square root of negative 6 squared, I would highly suggest putting that in parentheses, minus 4 times a times c, all divided by 2 times a. Now, probably the number one error that people will make when using the quadratic formula is figuring out the value of the number under the square root. That is what's known as the discriminant of the quadratic, and we'll talk about that a little bit more as this unit progresses, okay? The discriminant. But of course, you can always take your calculator, always. You can always open it up, right? And then simply put it in. Always include the negative b in parentheses. Negative 6 squared minus 4 times 1 times 1. All of that is to just get the number under the square root. Notice I didn't even put the square root over it because I'm very likely going to have an irrational number when I do that. So all of that is equal to 32. Could I do that by hand? Absolutely. But it's very convenient to do it on your calculator. Let's go back into full screen. Now negative 6 is positive 6 plus or minus the square root of 32 divided by 2. Now I want to write this in simplest radical form. The first thing I'm going to do is simplify the radical. I am not going to do the division by 2. Otherwise, the square root of 32, you might think, oh, I'll divide 32 by 2 and I'll get 16 and I'll have the square root of 16. No. Never allow a number outside of a square root to divide into a number inside of a square root. Think of that number as almost being, trapped in there. You can't touch it, not with the 2. All right, so what am I going to do? I'm going to leave the 6 alone. I'm going to rewrite the square root of 32 as the square root of 16 times the square root of 2, all divided by 2. I'm going to make the square root of 16 into 4 Now, I want you to almost view the 4 times root 2 as being like 4x. All right? That's all. And I want you to keep in mind that division by 2 distributes. So 6 divided by 2 is going to be 3, and 4 divided by 2 is going to be 2, right? So I get 6 divided by 2 and 4 divided by 2, and I get 3 plus or minus 2 times the square root of 2. Now, this answer hopefully looks familiar, because if I skip back a page, I see that my answer from completing the square is 3 plus or minus 2 times the square root of 2. I would actually claim that this problem is maybe even more easily done using completing square than using the quadratic formula, especially because of all the simplifying I have to do at the end. If I could just leave my answer this way, which I actually prefer, then maybe the quadratic formula is better. But I actually think using completing the square is easier on this one. Whatever. Today's lesson's on the quadratic formula, not particularly on completing the square. Now let's take a look at letter B quickly. Use your calculator to determine the solutions to the nearest hundredth. So these are irrational answers because we've got that radical 2, and the square root of 2 is an irrational number, and anytime we multiply an irrational by a non-zero rational number, we get an irrational number, then we add it to an integer, we still have an irrational number, blah-de-blah, right? Not interesting. But sometimes we want to know these answers to the nearest tenth, hundredth, whatever. So that's a calculator piece. Pause the video now and see if you can figure out these two answers to the nearest hundredth. Pause the video and go ahead and do that. All right, well, we've got two roots, right? One of them, maybe I'll call it x1, is equal to 3 plus 2 times the square root of 2. And the other one is 3 minus 2 times the square root of 2. Again, this really isn't that difficult in terms of calculators. 3 plus 2 times the square root of 2. That gives me 5.82. Now, if I really wanted to try to make it quicker, I could then go back up and delete that if this really is quicker. And there's my other one, right? So I've got my two answers. All I need now is to pick up my sheet of paper and write them down in terms of their rounded version. 3 plus 2 root 2 is 5.83, and 3 minus 2 root 2, 0.17. All right, and again, in many practical problems, you actually want your two answers rounded to some decimal accuracy. It's very rare that you actually want it just looking like that. All right, let's keep practicing with the quadratic formula. Exercise number 3. Which of the following represents the solutions to the equation x squared minus 10x plus 20 is equal to 0? All right, well, I've got the quadratic formula just sitting there written. Why don't you go ahead and see if you can use it to figure out which of these four choices is correct. And again, this is another one where because the leading coefficient's equal to 1 and because b is even, completing the square would work great to figure out the right choice. But let's use the quadratic formula. All right, so here we've got a situation where, where I just highlighted the formula. A is 1, B is negative 10, and C is 20. So using my quadratic formula, we have negative 10, negative 10, plus or minus the square root of negative 10 squared minus 4 times 1 times 20, all divided by 2 times 1. Negative 10 is just positive 10 plus or minus. There I would have 100 minus 80, which is just 20 underneath the radical, all divided by 2. That's going to be 10 plus or minus the square root of 4 times the square root of 5, all divided by 2. That's now going to be 10 plus or minus 2 root 5 over 2. And again, we're going to distribute that division. 10 divided by 2 is 5. 2 divided by 2 is 1, which I'll write just for the moment, right? But of course, 1 times the square root of 5 is just the square root of 5. So we have 5 plus or minus the square root of 5. Choice 4. Again, honestly, the beauty of completing the square versus, the beauty of completing the square versus the quadratic formula is that none of this kind of business are you doing, right? So you pretty much are getting almost all the way to here without having to simplify all this, fraction work. Let's keep going. Factoring versus formula. Although the quadratic formula is most helpful when a quadratic expression is prime, i.e. not factorable, it can be used as a replacement for the zero product law in cases where the quadratic can be factored. So we spent quite a bit of time on the zero product law, i.e. factoring an equation set equal to 0, then setting each factor equal to 0. But the quadratic formula works in all cases, whether a quadratic is prime, not prime, it doesn't matter. So let's take a look at that in a situation where we can factor. Exercise number 4. Solve the quadratic equation shown below in 2 different ways. Letter A, by factoring, and B, by using the quadratic formula. All right, so let's review the factoring, right? Letter A. 2x squared plus 11x minus 6 is equal to 0 by factoring. All right, well, this is one of our more challenging factoring problems because our leading coefficient is not equal to 1, right? In this case, we use that AC model or method of factoring. We're looking for 2 numbers whose product is equal to negative 12 and whose sum is equal to positive 11. Those 2 numbers are negative 1 and positive 12, right? They have a sum of positive 11 and a product of negative 12. So now I'm going to rewrite my quadratic as 2x squared plus 12x minus 6 is equal to 0. I'm now going to factor by grouping like this. I'm going to factor a 2x out of the first set of parentheses. I'm going to factor a negative 1 out of the second set of parentheses. I'm going to extend my page, give myself a little more room. I'm left with x plus 6 times 2x minus 1 is equal to 0. I'll set each of these factors equal to 0, and that will give me x is equal to negative 6 as one of my roots, and x equals positive 1/2 as the other root. Awesome. So just, a little review of the zero product law, AC method of factoring, all of that. Great. But now, the cool part is that the quadratic formula will also solve this and should give us negative 6 and positive 1/2 as answers. Pause the video now and use the quadratic formula to work your way through this problem and see if you get those answers of negative 6 and positive 1/2. All right, let's do it. So kind of do this. All right. What do we have? We have a is equal to 2, finally an a that's not equal to 1. We have b is equal to 11, and we have c is equal to negative 6. So x is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, again, most important part of this is really getting that number correct under the square root, known as the discriminant, right? So if I just take my calculator, 11 squared minus 4 times 2 times negative 6, and that gives me 169 under the square root. Now, what's cool is most of the time, the number under the square root is not a perfect square. But this time, 169 is a perfect square. It happens to be, right, 13 squared. So this is negative 11 plus or minus 13 all over 4. So my 2 answers, if you will, x1 is negative 11 plus 13 over 4. And that's going to be 2 divided by 4, which is 1/2. And then my second root is going to be negative 11 minus 13 divided by 4, and that's negative 24 divided by 4, and that's negative 6. And by comparison, there's those same answers. Side note, if the discriminant, right, 11 squared minus 4 times 2 times negative 6 is a perfect square, then what that really tells us is that our answers are rational numbers and our original quadratic could have been factored. All right, so sometimes when I don't know whether or not a trinomial can be factored, I'll just take a look at whatever is underneath the square root, that b squared minus 4ac, and if it's a perfect square, then I know my quadratic can be factored. All right, because it would give me rational roots as opposed to irrational roots. Now, you got to get practice, right? So that's what this last problem is all about. The quadratic formula is very useful in algebra. It should be committed to memory with practice. So let's get a little bit of practice. Exercise number 5. Solve each of the following quadratic equations by using the quadratic formula. Some answers will be purely rational numbers, and some will involve irrational numbers. Place all answers in simplest form. Awesome. Well, I'd like you to pause the video now and take a shot at letter A. All right, maybe the answers are rational like in the last problem. Maybe they're irrational like in the previous two problems. Either way, see what you get for letter A. Pause the video now. All right, let's do it. So in letter A, we've got A is equal to 3, B is equal to 5, C is equal to 2, X is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 2, all divided by 2 times 3. All right, that's going to be negative 5 plus or minus. Now, if I do 5 squared minus 4 times 3 times 2, I actually just get a 1 underneath the square root. I like that a lot because the square root of 1 is just 1. So I'm going to now have two roots. One of them is going to be negative 5 plus 1 divided by 6, which is negative 4 divided by 6, which is negative 2/3. My other root is going to be negative 5 minus 1 divided by 6, which is negative 6 divided by 6, which is equal to negative 1. So it may seem like you should never get two answers that are both negative or both positive, but you totally can. And again, these two answers being rational numbers means that you could have actually solved that by factoring. Who knew? The quadratic formula is still great. So let's have you do a little bit more. Letter B, why don't you go ahead and pause the video and try to solve that one by completing the square. Not by completing the square, but by using the quadratic formula. What lesson are we on? What lesson? Okay, go ahead. All right, let's do it. I can't remember what lesson we're doing. Completing the square and the quadratic formula are very, very related topics. So I will often intermix their terminology, and I really shouldn't. Here we go. A is 1, B is negative 8, C is 13. Let's do it. X is equal to negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 13, all divided by 2 times 1. Again, you want to work out what's underneath the square root, but when we put that into our calculator, we kind of crank through it. Whoops, we get a positive 8 plus or minus the square root of 12 divided by 2. The square root of 12 is not a nice number, but it can be simplified into the square root of 4 times the square root of 3, all divided by 2. That's going to be 8 plus or minus 2 root 3, all over 2. Again, keep in mind we have to do both of those two divisions. 8 divided by 2 is 4. 2 divided by 2 is 1, so I won't write it down. And we just have 4 plus or minus the square root of 3. All right, so in that case, we have irrational roots. We would have never been able to solve this one by factoring. Let's take a look at the last two really quickly together. We're not going to work on them together, but let's take a look at them. Letter C. 2x squared plus 5x minus 8 is equal to 7x minus 3. Like so many things involving solving quadratics, we can only use the quadratic formula if the equation is first set equal to 0. So the last thing I'd want to do here right now is say, well, a is equal to 2, b is equal to 5, and c is equal to negative 8, because we're not equal to 0, we're equal to 7x minus 3. So just like the zero product law, and like completing the square, well actually no, completing the square, it doesn't have to be equal to 0, but certainly like factoring, right, we need this thing to be equal to 0. So simple enough, right? To do that, I'll subtract a 7x and add a 3 to both sides. That will give me 2x squared minus 2x minus 5 is equal to 0. Okay, now that we have that, we can use the quadratic formula. Pause the video now and see if you can work through this the rest of the way. All right, let's do it. So we've got a is equal to 2, b is equal to negative 2, and c is equal to negative 5. So x is going to be negative b, which is negative negative 2, plus or minus the square root of negative 2 squared minus 4 times 2 times negative 5. Lots of negatives underneath that square root. That's where it's really helpful to use your calculator. But if you use your calculator to figure it out, what happens is we get a 44 underneath the square root. 44 is not a perfect square, so we can't just find its square root in some nice way, but we can simplify it as the square root of 4 times the square root of 11, all divided by 4. That's going to give me 2 plus or minus 2 root 11, all divided by 4. Now, one thing that I'd like to point out is up to this point in time, right, whenever we had sort of like two numbers sitting here, we typically had a 2 down here, so we would just divide a 2 in here and divide a 2 in here. What we would now want to do is we'd want to cancel a common factor of 2 from all of them. So we're literally dividing this by 2, we're dividing this by 2, we're dividing this by 2. So we get 1 plus or minus the square root of 11, all divided by 2. Alternatively, you could write it as 2 over 4 plus or minus 2 root 11 over 4, and then simplify both of those 2/4 into 1/2. That would be fine as well. The key is to identify if all three numbers that are outside of the radical have a common factor. If they do, divide that common factor out, and then you'll have your final simplified answer. All right, what I'd like you to do in the last problem, letter D, is I'd like you to rearrange it so it's equal to 0, and then I want you to work it out using the quadratic formula. All right, so the first thing I want to do, I've got a 3x squared here, I've got a negative 2x squared there, so I'm going to move all of this over to the other side by adding a 2x squared, adding an x, and subtracting a 9. Let's start with that. Here we go. 2x squared plus x minus 9, 2x squared plus x minus 9. That's going to give me 5x squared plus 8x minus 4 is equal to 0. I now can say a is 5, b is 8, c is negative 4. X now will be negative 8 plus or minus the square root of 8 squared minus 4 times 5 times negative 4, all divided by, wow, 2 times 5. Very rare that I get an a value that large. Everything's looking good though. That's going to be negative 8 plus or minus the square root of 144, all divided by 10. 144 is a nice perfect square. I can actually take its square root in a nice way. That's equal to 12. So I know my two answers are now going to be rational numbers. X1 is going to be negative 8 plus 12 divided by 10. That's going to be 4 divided by 10. Make that actually look like a 10 and a fraction bar. And that's going to give me one of my roots is 2/5. And my other root is going to be negative 8 minus 12 divided by 10. That's going to be negative 20 divided by 10. And that's a root of negative 2. All right, so the quadratic formula, fantastic. It can solve any quadratic equation, an equation where the highest power is x squared, highest power is 2, as long as that equation is set equal to 0. Now, some of these equations, again, could be solved using factoring, like letter D and like letter A. Both of those you could have factored in order to solve, but it's hard to know that, right? And if you've got sort of large numbers, then maybe it's easier to just use the quadratic formula. Sometimes you're forced on an exam, like literally the exam says use the quadratic formula, or use factoring, or use completing the square, right? Which are your three major ways of solving quadratic equations. But the one that will always work will be the quadratic formula. Completing the square will always work as well, but oftentimes can be extremely messy depending on what the values of A and B are. All right, let's wrap this up. Now, there really wasn't anything new that we did today that you didn't do in Algebra 1, but the quadratic formula is probably buried deep within your head, right? It's a simple formula that as long as we've rearranged our quadratic equation into the form a times x squared plus b times x plus c equals 0, we simply take the values of a, b, and c, we substitute them into the formula, we do some arithmetic, and we'll get our two answers. The formula will also lead us to really understanding a lot of other things in this unit, such as when do quadratics have no roots at all? When do they have no solutions whatsoever? What does that mean graphically, right? There's going to be a lot of things that we're going to be able to explore because we have the quadratic formula. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.